So in our previous class, we learned how to find the derivative of implicitly given function, how to find the implicit differentiation. Okay, so in this lesson, in part 2, related rate. So this is actually the real world application of the the concept that we just learned in the previous section. All right. So if several variables or quantities are related to each other and some of the variables are changing at a known rate, then we can use derivative to determine how rapidly the other variables must be changing. So basically in this section, our goal is to find the rate of change with respect to time. So it is very important in many situations to find the rate of change of something with respect to time. For example, if you are a manager of a company and if you want to find how fast your profit is changing over time, then what you do is you have a profit function and then you find the derivative of the profit function with respect to time. So you can tell how fast your profit is changing, how fast it's increasing. Okay. And in the same way, if you have a cost function and if you want to see how fast the cost is changing over time, per year, per month, per day, then you can differentiate your cost function with respect to time. So that will give you the rate of change uh, over time, okay, with respect to time. So before we actually solve problems from the real world situation, so let us quickly do one simple question here. So how it, what I mean differentiate with respect to t, okay, differentiate with respect to time. So how we do it, let us learn that skill and then we apply that skill to solve real world problems, okay? So suppose x and y are both functions of t and we are given a function x cubed plus 2xy plus y squared equals 1, and we are given the value of x and value of y, x equals 1, y equals -2, and dx over dt is also given, which is 6. Then we want to find dy over dt. So same idea that we learned in the previous section in part 1. So you differentiate both sides with respect to t. Okay, so step 1, differentiate with respect to differentiate with respect to t both sides. So then you'll have d over dt, not dx, dt. Keep that in mind. We want to differentiate with respect to time. That's the question. That is the question, okay? And x cubed plus 2xy plus y square and equals d over dt 1. And now x cubed plus d over dt, I can write that 2 there, so xy plus d over dt y square equals derivative of 1 is 0. Now x and t, again different variables, so you will use the power rule, 3x square, and write 1 factor extra plus 2. X and y are both function of t here, so we will use product rule again. So we have d over dt x and y. So as you know that this is u, this is v, the formula for product rule is um, d, I mean u dv over dt plus v du over dt. So in this case, u means x, dy over dt plus v means y, dx over dt. So let me just copy that down. 2 times x dy over dt plus y dx over dt, and then plus derivative of y squared with respect to t, because different variable, so we'll write 2y dy over dt. So whenever you have this different variable, y and t, then you use the power rule, but you must write one factor extra, all right, equals 0. And now this will be 3. So you write all the, now you can substitute the value because we are given all these values. So let us plug in the value there. So now, or substituting the value, substituting values of x, y dx over dt, we get 3, x means 1 square, dx over dt is 6, plus 2, x is 1, dy over dt, that's what we want to find, plus y is -2, dx over dt, we already know, which is 6, plus 2y, y is -2, dy over dt, that's what we want to find, equals 0. Now, this will give me, the first term will be 18 plus 2 dy over dt minus 6 times 2 is 12, times 2 is 24, plus, and positive and negative, negative 4 dy over dt. So this will, if you equals 0, so 2 dy over dt minus 4 dy over dt, you're going to get -2 dy over dt equals, this will be -24, and 18, you get 6, and it will be +6 on this side. So your answer, dy over dt, is going to be -3. Okay, now that you know what it means to be, differentiate with respect to t, so let us solve some of the real world problems. Okay, so in this section, I suggest that you follow this 6-step method, and you will be able to handle pretty much all the questions related to the related rates problem. Okay, I suggest you follow this 6-step. First, you read the problem carefully. Make sure you understand what is given and what is unknown. And then, if possible, sketch a diagram and label the various parts. Identify the quantities that are changing and assign them variables. Write an equation relating the variables of the problem, or write formula. I would say sometimes just writing formula would help. Use implicit differentiation to find the derivative of the equation in step 3 with respect to time. And then substitute the unknown values and simplify and solve for desired rate. So let us use those 6-step method. Step 1, read the questions carefully. Make sure you understand and what is given and what is unknown. So a small rock is dropped into a lake. Circular ripples spread over the surface of the water, with the radius of each circle increasing at the rate of 3 over 2 feet per second. Find the rate of change of the area inside the circle formed by the ripples at the instant the radius is 4 feet. So if you throw a rock, if you drop a rock in a lake, then you can see that the circular ripples actually spread over the lake. Okay, and it's increasing at the rate of 3 over 2 feet per second. And we need to find the rate of change of the area inside the circular the circular ripples, the circle formed by the ripples at the instant the radius is 4 feet. So let us draw a diagram. So it's a circle and the radius is r. Let r be the radius. Okay, then what is given here? Step 1, we are done. So we read the questions, and then we understand the question, and then we actually did step 2 also. We draw this diagram, and now we need to label the various parts. So what is given here is that we already labeled the parts, which is actually the radius r. This one is radius r. And so what is given? The radius of each circle increasing at the rate of 3 over 2 feet per second. So that is rate of change. And in the language of calculus, we write derivative. Okay, dr over dt is given, which is 3 over 2 feet per second. So whenever you see the word at the rate or per second, you see the word per second, per minute, per day, per month, per year. So that represent rate. Okay, so that represent rate. So in the language of calculus, that rate of change is actually derivative. So we use calculus symbol to represent the information. And then another information given is 4 feet. The radius r is 4 feet. So this is given. And what we need to find the rate of change of the area. So that means find dA over dt. That's what we want to find. All right. So step 1 and 2 is done. Step 3, write an equation relating the variables of the problem. So there are two variables, you see, a and r. So what is the relationship between a and r? Area of a circle. In another word, write the formula. So we know area of a circle is given by pi r square. And then step 4, use implicit differentiation to find the derivative of the equation. So we'll find dA over dt. So differentiate both sides with respect to t. So you will get d over dt pi r square. So equals pi, and r and t different variables. So what we're going to do is we write, we use the power rule, 2r, and then dr over dt. Because r and t are different variable, we must write that one factor extra, as we know from our previous section. Okay, implicit differentiation. So that's what we got. Step 3 is done. Step 4 is also done. Use implicit differentiation to find the derivative. So we found the derivative dA over dt to be this. Now substitute the known values and simplify. So what is given is d. Let us substitute the value. Substitute the values of dr over dt and r. So then you get dA over dt equals pi to r is 4 and dr over dt is 3 over 2. So you will get 12 pi, which is approximately 33.7 feet. Because this is the rate of change, it's feet square, because it's area. So feet square per second. So the The area of the circular ripple is increasing at the rate of 37.7 feet square per second. Okay, all right. Now let's work example 3. John Landscaping. The total revenue from the yard maintenance of X homes is given by R of X equals 1000X minus X square, and the total cost is given by C of X equals 3000 plus 20X. Suppose that John is maintaining 10 homes per day. At the moment when the 400th customer is signed, at that moment find the following. We want to find rate of change of the total revenue, rate of change of the total cost, and rate of change of the total profit. So there are 3 things that we want to find. So first of all, read the questions carefully. Step 1. Step 2, draw a diagram if possible, but in this case, there is no diagram required. Let me just write down whatever information given here. Okay, so the revenue is given, which is given by R of X, that is 1000 X minus X square. Cost function is also given, cost or total cost, C of X is given by 3000 plus 20X. This is given. And John is maintaining X homes. Remember, X represents the number of homes. So given here is X equals 10 home. Okay, 10 home per day. So that is clearly a rate of change. So dx over dt. Okay, that's the derivative. You see the word per, that is the key word, per day. John is maintaining 10 homes per day, so that we can represent that information by dx over dt. And at the moment when 400th customer, so that means X is given 400. So these are the information given. Now we can, okay, let's look at part A. We want to find the rate of change of total revenue. So this is the total revenue, and we want to find rate of change of this. So in part A, we want to find dr over dt. So you just differentiate both sides with respect to t. You're going to get d over dt 1000 x minus d over dt x squared. So this gives me 1000 dx over dt minus, this will be 2x, since x and t are different variables, so we'll write that one factor extra. So step 3 is actually the formula, which means the function is already given. Step 4 is differentiate with respect to t both sides, we did it. And step 5 is substitute the value. Substitute values of x and dx over dt, so that you'll get 1000 dx over dt is 10 minus 2, x is 400, dx over dt is 10. So if you simplify, you will get $2,000 per day. Okay, so the revenue is increasing at $2,000 per day. Now let's look at B. Let's try solving B. Rate of change of the total cost. So the cost function is already given, so we want to find rate of change, means dc over dt. So differentiate both sides with respect to t. So you will get d over dt of 3000 plus d over dt of 20x. So this gives me 0 plus this will be 20 dx over dt. Now substitute the value. So your dc over dt will be 20 times 10, which is given by $200 per day. So the cost is increasing at the rate of $200 per day. Now part C, rate of change of total profit. Okay, so we want to find rate of change of total profit. So in part C, we need to find dp over dt, where p is profit. So we know that profit P equals revenue R minus cost C. So dP over dt equals dr over dt minus dc over dt. Now substitute the value because we already know what is dr over dt. So substituting values, we'll get dr over dt is 2000 minus 200 equals 1800 per day. So the profit is increasing at the rate of $1,800 per day. Let's look at another example. Example number 4. A 10-foot ladder is placed against a building. The base of the ladder is slipping away from the building at a rate of 1 foot per second. Find the rate at which the top of the ladder is sliding down the building at the instant when the bottom of the ladder is 6 feet from the base of the building. Okay, so let us draw a diagram. So here is a building. Let's say this is building, and here is a ladder. And this one is the ground. Okay, this one is building. This is ladder. And let us suppose that, and this one is ground. Let us suppose that this is our x, this is our y, and they are variable because for some reason, maybe this ground right here is slippery and it's the ladder is slipping away. Okay, so the ladder is actually slipping away in that direction. And but the ladder, the length of the ladder is fixed. It is 10 feet. That is fixed. So the only variable that we have is this side x and then this one, because when the ladder slip away like this, then this part will come down. Okay, the portion of the ladder will come down. So our goal is to find out how fast the ladder is coming down on the side of the building. So we draw the diagram and we actually label them. And so let us use the mathematical symbol to represent all the information given. Okay, the ladder is 10 feet. The base of the ladder is slipping away from the building at a rate of 1 foot per second. Look at the word per. So that means this dx, because this is slipping away, so dx over dt is 1 foot. Find the rate at which the top of the ladder is sliding down the building at the instant when the bottom of the ladder is 6 feet from the base. So this ladder is actually from here to here. It is given to be 6 feet. So x is given to be 6 feet, and we want to find dy over dt. That's what we want to find. So step 1 is done. Step 2, draw the diagram and then, write down all the information, what is given and what we want to find. That's done. Step 3 is, look at the relationship between x, y, and then the ladder. Okay, we want to find a function, a formula that will represent the relationship between x, y, and the ladder 10 feet. So clearly this is a right triangle. Okay, so this looks like this is a right triangle, provided that the building is actually the straight. Okay, we assume that. So it's a right triangle. So using Pythagoras theorem, using Pythagoras theorem, we can say that x squared plus y squared equals 10 squared, right? Now we have the function, we have the equation. So what we do is, now we'll write down, we differentiate both sides. We use the implicit differentiation, differentiate both sides with respect to t. So since x and t are different variables, so using the implicit differentiation, we write 2x dx over dt plus 2y dy over dt equals 0. Now the next step is to substitute the value. Substitute values of x, y, and dx over dt. So 2x is given 6, dx over dt is given 1, plus 2y. Okay, y is not given explicitly, but we can use the same relationship, because when x is, okay, in Pythagoras theorem, when x equals 6, then x squared plus y squared equals 10 squared becomes 6 squared plus y squared equals 100. So you'll get y squared equals 100 minus 36, which will be 64. So y is plus minus 8. But since we are talking about the length here, distance, no negative sign. So y equals 8. We already got that. All right. Sometimes you need to go back to the figure, and then, whatever variables information is not explicitly given in the question, you may want to find that using the, relationship, using some geometry from high school. So we got y is 8 and dy over dt equals 0. So this gives me dy over dt, 16 dy over dt equals minus 12. So dy over dt equals minus 12 over 16. That's going to give me minus 3 over 4. Okay, so the unit is feet per second. So it's negative. Notice that we already said earlier that this is decreasing. It's coming down. Okay, coming down towards the ground. So it's negative. So what we can say is that the ladder is moving down. So this means the ladder is moving down the wall at the rate of 3 over 4 feet per second. All right. Okay, so let's look at another example. I think you got the idea how we can find, um, how we can find something is changing with respect to time. But let's do one or more problem just for fun, okay? So example 5. Suppose one car leaps an intersection traveling north at 30 km per hour and another is driving east away from the intersection at 40 km per hour. At one point, the northbound car is 3 km north of the intersection and the eastbound car is 4 km east of the intersection. At this point, how fast is the distance between the cars changing? So after reading the question, then try to, sketch a diagram, and that will help to understand what is given and what we want to find. So you know that the direction is north, south, east, and west. So what is happening here is that suppose one car leaves an intersection traveling north. So car A, let's say here is a car. This is traveling north. Okay, it's going that direction. Let's say this is car A. Another, this is the intersection. This is the intersection. And another car is traveling east away from the intersection. So this means this car is traveling to that direction. Okay, let's say this is car B. And at what rate? The first one, this car is at the rate of 30 kilometer per hour, and this car is 40 kilometer per hour. So whenever we see the word per hour, kilometer per hour, that represent that tells you that it's the derivative. Okay, it's the derivative. So let us suppose that this is our x and this is our y, because both are variable. As the car, let's say, as the car A travels towards north, the value of y is changing, so it's variable. As the car B travels on that direction on towards east, then the x value changes. It's another variable. So we can write dy over dt equals 30 and dx over dt equals 40. This is given. And at one point, the northbound car is still 3 kilometers north of intersection, northbound. So this one is given 3. Y equals 3 is given at some point. This will be 3 kilometers from the intersection, and this will be 4 kilometers from the intersection. This is given. Okay, so let us write that. So what is given here is dy over dt is given 30 kilometer per hour, and dx over dt is given 40 kilometer per hour, and x is given, y is given 3 kilometer and x is given 4 kilometer. Now our goal is to find how fast the distance between these two cars is changing. All right, that's what we want to find. So how fast the distance between A and B are changing. Let us suppose that this is Z. So we want to find dz over dt. All right. Now step 1 is done. We read the questions carefully. step 2 is done. We draw the diagram and we label the parts, and we write down all the information using our mathematical language. And step 3 is to figure out the relationship between x, y, and z. Okay, what is the relationship between these three variables? Clearly, this one is a right triangle again. So using the Pythagoras theorem, so using Pythagoras theorem, we can write z square equals x square plus y square. Notice that in this case, x, y, z all are variable. Okay, unlike in our previous example, the ladder example, where the ladder is constant. But in this case, x, y, z all are variables. All right, so we got the formula here, and now we differentiate both sides with respect to t. So d over dt z square equals d over dt x square plus d over dt y square. So this gives me 2z dz over dt equals 2x, because x and t different variable, dx over dt plus y and t different variable. So we have 2y dy over dt. So derivative is done. Step 4 is done. Now step 5 is substitute the value. Substitute values, and values of x, y, dx, dx over dt and dy over dt. So let us substitute that values of all of these, as well as z. So 2 times z. Oh, z is not given explicitly there, but again, as in the similar to previous example, we can calculate what is the value of z here. Okay, using the Pythagoras theorem, we can calculate z square equals x square plus y square. So which means x is 4 square plus 3 square. So z square equals 16 plus 9 is 25. So z equals 5. So 2 times z is 5, dz over dt, we want to find that. And this will be 2x is 4, dx over dt is 40, plus 2y, y is 3, dy over dt is 30. So 10 dz over dt equals, if you simplify it, you'll get okay, 8 times, this will be 320 plus 180. So 10 dz, dz over dt will be 500 over 10, which is 50. Okay, so this means car A and the distance between car A and car B is increasing at the rate of 50 kilometer per hour. So the distance between the cars changing at a rate of 50 kilometer per hour. All right, so now the last question. I trust that you already know how to solve related rate problems, but we want to try one more question just for fun, okay? A cone-shaped icicle is dripping from the roof. The radius of the icicle is decreasing at a rate of 0.2 centimeter per hour while the length is increasing at a rate of 0.8 centimeter per hour. If the icicle is currently 4 centimeter in radius and 20 centimeter long, is the volume of icicle increasing or decreasing, and at what rate? Okay, it is a cone shaped icicle. So let us draw the diagram. So this is the ice, and the ice is actually dripping from the roof. So maybe because the temperature is increasing, so when the temperature is increasing, the ice is melting. Okay, so the ice is melting, and what is given here is that the radius of the icicle is decreasing at the rate of 0.2 centimeters. So radius is decreasing. So that means what is given here is dr over dt equals negative, because of it is decreasing, negative 0.2 centimeter per hour. Okay, now what is another information given is while the length is increasing, so length means uh, let's write down that as h. So the length of the cone is h, this is h, this one is your r, radius. Okay, so the length is increasing, so dh over dt is increasing 0.8 centimeter per hour. And that makes sense because when it is melting, this length will increase, whereas the radius is decreasing. If the icicle is currently 4 centimeter in radius, so r is given 4 centimeter, and 20 centimeter long means h is given 20 centimeter. So these are the information given. All right, step 1 is done, reading the question. Step 2, drawing the diagram and labeling the parts and writing the information given in the questions using mathematical symbol. All these things are done. Step 3, we need to write down the formula. We need to write down the relationship, of function with the relationship of h and r. hr, and then we want to find the volume of the icicle increasing or decreasing. So we know the formula that volume of the icicle cone is volume of cone V is 1 over 3 pi r square h. We know the formula. Now step 4 is differentiate both sides with respect to t. So dv over dt equals d over dt. I can write that 1 over 3 pi because this, pi over 3 is just a constant. Let me write that down like that. And d over dt, r square and h. Now we want to find the derivative of r square and h using the product rule. So use the product rule here. Okay. So using the product rule, pi over 3, we know the formula. Let me just calculate this here, and I just, copy and paste. So d over dt of r square h, this is your u, this is your v. So you know the formula u dv over dt plus v du over dt. So u means r square dh over dt plus v is h dr square over dt. So this will give me r square dh over dt plus this guy will be h, and then r square, derivative of r square with respect to t is, because they are different variable, we write 2r and then dr over dt. So similar to the concept that we learned in the previous section. So let me just copy that derivative here. So derivative of this is r square dh over dt plus 2rh dr over dt. Now we are done with the derivative. Step 4 is done. Step 5 is substitute the values. substitute all known values. So you will get pi over 3 r square. R is 4 square and dh over dt. dh over dt is given to be 0.8 plus 2r. R is 4, h is 20, and dr over dt. So dr over dt is given to be negative 0.2. And if you simplify it, your dv over dt will be approximately negative 20. So remember, this dv over dt, so what is the unit? It's the volume, okay? It's the rate of change of volume. So that means negative 20 centimeter cube per hour. All right. So what it means is the height, I mean the length, I mean the volume, sorry, the volume is decreasing. This means the volume is decreasing at about 20 centimeter cube per hour. So this is all about related rates. So I trust that you'll be able to handle pretty much all the questions of this type. And this much for today. Thank you.